viewers, we're gonna take you through the story for A-level physics paper 2. And this video, I'm going to go through the topic of magnetism and alternating current. In particular, we shall look at calculations involving alternating current for parallel circuits of inductors, resistors, and capacitors connected to an AC source. So this video is suitable for students in both Senior 5 and Senior 6 offering physics as part of their combination. So this is the other subtopics in this topic of magnetism and alternating current. And I think you realize that all of them are ticked, meaning that after covering this video, we shall have completed the section of magnetism and alternating current. And I think you remember it was the pending section in physics paper 2. So when we finish this video, it implies that we shall have officially completed the syllabus of physics paper 2. Maybe from after this video, what I'm going to do, I'm going to combine all these short videos into one video, because some of you are facing challenges based on the comments you write to identify to search for some videos. Some of you inbox and say, I'm not seeing this video, I'm not seeing this video. So what I'm going to do, I'm going to combine each section by section. I'll combine videos of physics section A alone, videos of physics section B alone, section C alone, section D alone, so that you can easily, so that once you get one video, you have got all what you need. Otherwise, I believe we have covered enough for physics paper 2. So like I've already told you, we are interested on this platform on the calculations, but these calculations are not the only ones which are as examinable. There are also experiments, definitions, explanations, and derivations. Actually, here we do calculations and derivations, but the other part of definitions, explanations, and experiments is not on this video, so it's not on this platform. So what I encourage you is to buy these books, because they contain all those parts. So for physics, there are 4 books: physics paper 1, physics paper 2, topical question bank, and its solutions. For mathematics, principal mathematics, there are still 4 books: math paper 1, math paper 2, termly past papers with marking guides, and a topical question bank. Subsidiary math is only 1 book which contains both notes and past papers. So for any of the inquiries or to get a copy, contact the author on this contact. Some of you are fun, you just go and try to look for them in bookshop, then you don't find them. Or some of you, if you find them, you'll find an old edition and you think it's a new, because someone who can pirate the book and just change and say edition 2025, therefore when you say edition 2025 you think it's the latest, yet someone has just changed the book cover. So I encourage you to contact the author so that you can get a genuine copy from a reliable source. So like we did in the previous video of series arrangement, even in power arrangement, we shall break down the video into 3 parts. The first part will be power arrangement of a resistor and an inductor. Next part will be power arrangement of a resistor and a capacitor. And the last part will be power arrangement of all the 3, that is resistor, inductor, and capacitor. So let's begin with the one for resistor and inductor. So in the previous video, we saw that for series, current is the same. Now when it comes to parallel, it is PD, which is the same. So PD across this is equal to PD across this, and is equal to this source PD. When it comes to current, this is the total current. It is broken down into 2. One flows through the resistor, another one flows through the inductor. So current through the resistor was given by IR equal to V over R. Current flowing through the inductor is that, and total current is equal to that. So like I told you in the previous video, here we can't say that this one is equal to this plus this, no, because in alternating circuits we use phasor diagram to get the resultant. We use phasor diagram. Always remember that. So phasor diagram for this above circuit, we already know that current through the resistor is in phase with its voltage, within phase with the voltage, but the current through the inductor lags behind the voltage by 90 degrees. So if the voltage is here, current will be down for the inductor here, because it has to lag behind the voltage. But when it comes to the current through the resistor, it is in phase, so to be here like that. That means that the phasor diagram will be in that form, where that is IR, that is V, and this is IL, meaning that we can get the resultant current. So theta is the phase angle, we have already said that. So from the phase angle, we can get the total current from Pythagoras theory. I squared is equal to IR squared plus IL squared. But I know I is V over Z. IR is V over R and IL is V over XL. So here I realize that V is common, so it can cancel to come up with that. Then put square root on both sides to come up with 1 over Z being equal to this. So here in this case, when I make this the subject, I'll be able to, that will be the impedance. Then for phase angle, still we shall say tan theta is equal to IL over IR. When you substitute, you'll come up with phase tan theta being equal to R over XL. So remember previously for series circuit, for series, these were not reciprocals. It was just Z is equal to R squared XL squared. Now here we get reciprocals in parallel. Even here for series circuit, it was XL over R. Now here we get the reciprocal of that, which now becomes R over XL. So with that, we can go through some questions. So question 1, still they are similar to the format of the questions in the previous video, but this time in the previous video they were in series. Now these ones are in parallel. So a 50 ohm resistor and a 0.1 Henry inductor are connected in parallel to a 60 Hz AC source. Calculate the total impedance of the circuit. So yeah, first we shall get the inductive reactance. Then from there we shall remember that one reciprocal of impedance is given by this. Therefore, impedance is 1 over that. Then substitute for this to give you the impedance they want. Question 2, a 30 ohm resistor and a 0.2 Henry inductor are connected in parallel to a 120 volt 50 Hz AC supply. Calculate Roman 1 the total impedance of the circuit and Roman 2 the current flowing through each component. So first of all, inductive reactance is that, meaning that impedance will now be 1 over this. Then you substitute for R for XL to give you this as the impedance. Then for Roman 2, they wanted current. So for current, you need to first get the, okay, for current, we already know the PD. So when I know PD and I know the reactance and the resistance, I can easily get the current. So here I'll come and say that for resistor it will be V over R, and for inductor it will be V over XL, and that's what they wanted. Question 3, a 25 ohm resistor and a 0.05 Henry inductor are connected in parallel to a 110 volt 50 Hz AC supply. Calculate Roman 1 the total impedance of the circuit and Roman 2 the power dissipated in the circuit. So first we shall get the inductive reactance, then you can get the impedance from 1 over square root of this, which substitute and get the answer. Then the power dissipated will be I squared R, because what is given is an RMS value. So if I say I squared R, it is okay. And also if I say V squared over R, it is still the same. I think you remember they are the same formulas. We covered them in the very first video for individual components. So if someone uses I squared R, you realize that you get the same answer. Question 4 says a 20 ohm resistor and a 0.25 Henry inductor are connected in parallel to a 100 volt 50 Hz AC source. Calculate the phase angle between the voltage and the current. So inductive reactance is that phase angle will come from tan theta equal to R over XL, substitute for R, and for XL then make theta the subject. And that's what they wanted. Then now shall go to resistors and capacitors connected in series. Sorry, connected in parallel. That's a capacitor, then that's a resistor. So current is different through each component, but PD is the same. So current through the resistor is that, current through the capacitor is that, and total current is that. So phasor diagram, we already know what leads the other. So in a capacitor, I think you remember, it is voltage which, so here it says, since IR is in phase with V, okay, and IC leads voltage by 90, it implies that IC also leads IR by 90. Okay, so that means that phasor diagram will be in this form. So I can use Pythagoras theory to get the total current. Substitute and cancel out the V's, then put square root. So similar to the previous one, only that what has changed was this. Instead of putting their inductive reactance, you have put their capacitive reactance. Same applies to the phase angle. Instead of putting XL, we shall put XC. Like that. So with that, we can go through these questions. Question 1 says, a 16 ohm resistor and a 12 microfarad capacitor are connected in parallel to a 50 Hz AC source. Calculate the total impedance of the circuit. So one shall first get the capacitive reactance, then you can get the impedance. Quote the formula, substitute, and get the answer. And that's what they wanted. Question 2, a resistor of resistance 30 ohms and a capacitor of capacitance 10 microfarad are connected in parallel to a 230 volt 50 Hz AC source. Calculate Roman 1, the total impedance of the circuit, and Roman 2, the current flowing through each component. So for impedance, you need to first get the capacitive reactance, then you can get the impedance. Quote the formula, substitute, get the answer. So for current flowing through each component shall come, and the good thing we know PD, so you can say current through the resistor is V over R, and current flowing through the capacitor will be V over XC. Question 3, a 45 ohm resistor and a 28 microfarad capacitor are connected in parallel to a 240 volt 60 Hz AC supply. Calculate Roman 1, the total impedance of the circuit, and Roman 2, the power dissipated in the resistor. So you need to first get the capacitive reactance, then you can get the impedance, code the formula, substitute, and get the answer. Then power dissipated is V squared over R, to give you that. Question 4, a 55 ohm resistor and a 35 microfarad capacitor are connected in parallel to a 100 volt 50 Hz AC source. Calculate the phase angle between the voltage and the current. So XC is that. Therefore, tan theta is equal to R over XC, substitute, and make theta the subject. So now shall go to where the three components are in parallel in that resistor, inductor, and the capacitor. So phasor diagram will be in this form. That is the current in the resistor and voltage. Then this is the current in the capacitor and current in the inductor. So if we consider current through the inductor to be greater than current through the capacitor, then the resultant will be IL minus IC, therefore to be downward. So you can now redraw the one which can help us to easily get the resultant current or the total current. So by Pythagoras theory, it means that I will be equal to I squared is equal to this squared plus this squared. So you shall come here and say that is that, then substitute, then cancel out the V, so that will be the impedance, the reciprocal of the impedance. Then from the phasor diagram, it means that tan theta is equal to this, substitute, and simplify to come up with this as the expression for the phase angle. So with that, we shall go through these questions. Question 1 says, a 48 ohm resistor, a 25 microfarad capacitor, and a 0.35 Henry inductor are connected in parallel to a 50 Hz AC source. Calculate the total impedance of the circuit. So we need the inductive reactance and also capacitive reactance. Then you can get the total impedance. Code the formula, substitute, and get the output as the impedance. Question 2 says a resistor with a resistance of 52 ohms, a capacitor with a capacitance of 9 microfarad, and an inductor with an inductance of 0.48 Henry are connected in parallel to a 230 volt 50 Hz AC source. Calculate Roman 1 the total impedance and Roman 2 the current flowing through each component. So you first need the inductive reactance and capacitive reactance, after which you can code the formula for impedance, substitute, and get the output. Then for Roman 2, current flowing through each component, the good thing we already know the PD, meaning that I can get now current. So the one through a resistor is V over R, the one through the inductor is V over XL, and the one through the capacitor is V over XC. So question 3 says a 38 ohm resistor, a 15 microfarad capacitor, and a 0.05 Henry inductor are connected in parallel to a 110 volt 60 Hz AC supply. Calculate Roman 1 the total impedance of the circuit and Roman 2 the power dissipated in the resistor. So one, we need to get the inductive reactance, capacitive reactance, and then the impedance. Code the formula, substitute, and get the answer they want. Then for power dissipated, we use V squared over R. Question 4. A 32 ohm resistor, a 7 microfarad capacitor, and a 0.18 Henry inductor are connected in parallel to a 100 volt 50 Hz AC source. Calculate the phase angle between the voltage and the current. So there we need the inductive reactance and capacitive reactance. Then you can quote the formula for tan theta and then substitute, then get the value for theta, and that's what they wanted. So that brings us to the end of this video. Thanks for watching, and very much in the next video.